Okay, I have decided to make this video on permutation because I'm going to use the lessons that we'll learn here in solving some of the problems that we have in the advanced GRE questions. So exactly what do we mean by permutation? Permutation. So the word permutation is just simply another word for saying that the number of ways of arranging n sets of objects. So for example, if someone tells you to find the permutation of n objects, so what that simply means is the person is actually telling you to find the number of ways by which you can arrange the n sets of objects. And normally, to find the number of ways of arranging n sets of objects, there is a unique formula for that, and that is given by, so you have n sets of objects, so that's going to be n factorial divided by the product of the number of times each of the object appears. So that is n factorial divided by, so let me write that down, the product of the number of times the number of times each appears. We're going to look at a couple of examples to demonstrate the usefulness of the formula I wrote down here. So this is n here. So for example, assuming you have so let me call this example 1. Maybe you're told to find the number of ways by which you can arrange A, B, and C. So manually, if you wanted to do this manually, what you would do is the number of ways of arranging this. So you start by arranging A, B, C. So you start by saying A, B, C. So A is still the first. Then A, C, B. So this is the first one. Then the next is when B is the first. B, A, C. And then you have B, C, A. And also when C starts, you have C, A, B. And then you have C, B, A. So these are the total number of ways of arranging the letters A, B, and A, B, and C. And then all in all, when you count them, you have 1, 2, 3, 4, 5, 6. So the number of ways, or the permutation of A, B, C is just is 6. So the permutation is 6. So based on the number of things we have here. But then, considering the formula we wrote here, if you look at A here, in the word A, B, C, A appears only one time. So that is A appears one time, B appears one time, and then C also appears one time. So to find the permutation of A, B, C, so we said the formula is the number of terms you have. So that is how many terms do we have here, or how many objects do we have? We have 3 objects, 1, 2, 3. So that's going to be 3 factorial divided by the product of the number of times each appears. So the number of times A appears is 1. That's 1 factorial times, so this will be the product of the factorial, so the factorial of the number of times each appears. So this is 1 factorial, then B appears 1 time, so that will be 1 factorial. So C appears 1 time, that will be 1 factorial. So this is just going to give you down 3 factorial is the same thing as 3 times 2 times 1, and then 1 factorial is just 1 times 1 times 1, and then this is just still going to give you 6. So you observe that instead of going through the manual process of listing down all of them, then you could just use the formula, and then you have your answer. And then the usefulness of all this is, for example, if you're given six different objects, and then you're told to find the permutation of the 6 different objects, then you'd observe that you're going to waste a whole lot of time by listing down all the set of possible arrangements of the 6 different objects. So that's why this formula is useful. Okay, we're going to look at another example to demonstrate the formula. So let's call that example 2. So assuming you're told to find the number of ways of arranging A, B, A, C. So this is quite different from this one, because in the first example, A, B, and C, they all appear just 1 time. But in this example, A appears 2 times, like you can see here, it appears 2 times, while B and C appear only 1 time. So just for illustration, I'm going to go through the manual way of of finding the number of arrangements of the four objects that we have here. So if you want to arrange this, so you first start with A, B, A, C. So you have A, B, A, C. And the next is going to be A, B. So I'm going to swap this A, B, C, A. And the next is A, B, C. And then you have A, C, B. So I've swapped this. Then you have A, C, B, A. Then you have A, C, A, B. Again, I swapped this. Then you have B. Let me not confuse things here. B, A, C, A. And then you have B, A, C. I swapped this. And then here we are done with all the A's. Now we are in the B's. So remaining one B. So you have B, C, A, and then you have C, A, B, A. So you can also have C, B, A. So these are the total number of ways of arranging this letter here, the letter A, B, A, C. You can see, and then if you look at the whole thing, I've listed down all the set of possible arrangements of A, B, A, C. So don't get a little shall I say, kind of be wondering why or how I got this. I already have my answers before. I already know how to do them before I actually came in. That's why it didn't take me a very long time to figure out how to list them. So anyway, if you want to count the number of ways I've listed there, you have 1, you have 2, you have 3, you have 4, you have 5, 6, 7, 8, 9, 10, and 11. So that means all in all you have 11 possible arrangements of A, B, A, C. Is it 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then let's see if we can. I think there's still one more. This is A here. A appears here, so we could have A, B, A. Okay, we could also have A, A, B. Yeah, they should also have A, A, B. So this is going to be C, A, B. Yeah, so it should be 12, not 11. It should be 12. Yeah, sorry for that. So that should be 12. So there are 12 possible arrangements of this. But then if we're going to use the formula we have here, the formula says the permutation of the number of ways of arranging n sets of objects is just the total number of objects we have. So look, we have 1, 2, 3, 4. So we have 4 objects. So that's going to be 4 factorial divided by then the product of the factorial of the number of times each of the objects appears. Now for A appears 2 times, B appears 1 time, and then C appears 1 time. So we're going to divide by the product of the number of times each of the objects appears. So it's going to be 2 factorial times 1 factorial times 1 factorial. And then this is going to give you 4 times 3 times 2 times 2 times 1 divided by, so this is 2 factorial, that's 2 times 1 times 1. So this is 24 divided by 2, and then you have 12. So we still observe that we obtained the same answer in doing this. So that tells us that the disadvantage of listing all these things is that sometimes if you're given 16, 17 numbers, it is most likely you're going to skip some. That's number 1. Then number 2 is you might make mistakes, and then number 3 is it takes a whole lot of time and it burns lots of time. You understand? So for example, in the exam, if you're told to do something like this, then you would have to begin to list so many things, which is going to burn a whole lot of time, of which you already have the formula. So just use the formula and then you have your solution. So I'm going to do one last example, so just to ground understanding. So assuming you are told to find the number of ways, so let's call that example 3, the number of ways of arranging success, S, U, C, C, E, S, S. So you want to find the number of ways of arranging success. So we said, according to the formula, the number of objects we have here is 1, 2, 3, 4, 5, 6, 7. So we have our n to be equal to 7. Alright, now the thing is, you have S here, you have U here, and then you have C here, while you also have E here. So you have four different objects here. So how many times does S appear? So you can see you have 1, you have 2, 3. So S appears 3 times. What of U? U appears just 1 time. And C, so C appears 2 times. It appears 2 times. So if you're told to find the number of ways of arranging the word success, so the number of ways is just going to be the n factorial like we have here. So you remember the formula here, it says n factorial, let me put that up, n factorial divided by the product of the factorial of the number of times each appears. So we come back here, so it says n factorial, which is 7 factorial, divided by the number of ways, the product of the number of ways. So for S we have 3 factorial times, for U that's 1 factorial, times for C that is 2 factorial. And then to simplify this, so we know 7 factorial is just 7 times 6 times 5 times 4 times 3 times 2 times 1. 6, 5, 4, 3, 2, 1. Yeah, divided by, so your 3 here is 3 times 2 times 1, then times 1 factorial is just 1, and then 2 factorial is just 2 times 1. And then when you begin to cross out, you observe that this 2 crosses 2 here, you have 3 crosses 3, and then 2 crosses 4 here, you have 2. So that means your solution is just going to be 7 times 6 times 5 times 2. And when you multiply this is 7 times 6, which is 42, 5 times 2 is 10, so 42 times 10, that's going to give you 420 ways. So imagine, assuming you wanted to go through the whole mechanical way of listing the whole thing, that means you have to list 420 things, and of which it is most likely you're going to make mistakes. So that tells you that the formula we have above still remains the most efficient way of finding the number of ways of arranging them n sets of objects. So I do hope you understand the topic now. Alright, well, if you have any questions, please feel free to drop them in the comment box below. Thanks for watching.